Hello everyone, my name is Greg Risterbin from Olympus SSA. I'd like to welcome everyone today to today's presentation, Maximize ROI with XRF, Tips to Achieve Speed, Simplicity, and Accuracy for Scrap Sorting. This presentation will review the challenges of the scrap recycling market today, the basics of XRF, and how XRF can help sort scrap faster. Our presenter today is Eric Gingras. Eric is the National Sales Manager for Olympus ANI and RVI products. Welcome, Eric.
Hello, happy to be here.
This webinar presentation will last approximately 30 minutes. If you have questions, please type them into the Q&A panel in the lower right portion of your screen during the presentation. The chat panel will not be monitored during the presentation for Q&A. If we are not able to get to your question during the live event, they will be addressed either personally by email or phone after the event. Now, I'd like to turn the presentation over to Eric Gingras. Eric, take it away.
Thank you, Greg. According to the U.S. International Scrap Recycling Institute, the U.S. annually processes more than 250 billion pounds of scrap material every year, which is equal to about the weight of 70 million cars. More than 8 million metric tons of non-ferrous scrap was processed in the U.S. last year alone. That's an awful lot of scrap to be processed. We're going to talk a little bit about today about the types of products that we have that are used for sorting scrap, challenges that the scrap market faces today. One of the challenges of sorting all of that scrap is determining the price of the materials. We all know that sorting scrap adds value at all stages of the recycling process. Sorting unsorted materials and sorted scrap is worth more than unsorted scrap. The value of scrap comes from the type and quantity of the metal. Simply put, the more pure copper, aluminum, or nickel that scrap has, the more valuable that it is. Another challenge is quality control. And there are two kinds of costs for material mix-ups. Both can be quite costly. One is shipping costs. If a load is rejected, it can be very expensive for the material, trucking, returning, and unloading, and also damaging your reputation. There's also process costs. Out-of-spec alloys can be costly, and process errors can be enormously expensive. So let's talk a little bit about what XRF is if you are unfamiliar. XRF analyzers essentially send an X-ray into a material, say metal. The instrument gets an X-ray back to what's called a detector. Those detectors pick up each element, which has its own energy signal by weight. This allows us to determine the elemental makeup of the metal, for instance. We can effectively detect from about 200 parts per million up to 2,000 parts per million with analytical confidence. Please keep in mind this is X-ray tube type technology. It's completely electrical and does not utilize radioisotopes. Let's talk a little bit about the periodic table. This is a question that often comes up. What elements can you detect with handheld XRF? Currently, handheld XRF has an effective range from magnesium to uranium on the periodic table. So if you move to the top left to the bottom right, magnesium would be the lightest element that can be effectively quantified using today's handheld XRF technology. What elements can we analyze? Well, it's almost all elements of significant value in the scrap industry, including precious metals. What elements are most difficult to analyze? Well, elements that are lighter than magnesium on the periodic table you see in front of you. Elements such as carbon and boron. So let's discuss how XRF can help sort scrap faster. The thing we want to remember is what's most important to a scrapyard. XRF can help you sort faster and increase your profits, which essentially will mean more pure scrap. Keep in mind that these are mobile handheld devices that can be used at any location in your yard. They weigh about 3.5 pounds, and they have the ability to separate over 550 different types of alloy grades. Most tests take less than 2 seconds. Matter of fact, about 90% of the tests that you'll make in the average yard will take less than 2 seconds. If there's not a lot of aluminum in your particular facility, then the majority of your tests will only take a few seconds. With these instruments, we're able to sort hundreds of non-ferrous grades that aren't distinguished by carbon content. Now, we will acknowledge that aluminums can be tricky. A lot of it has to do with surface preparation and light element testing. We'll get into that in a minute about how you can make the process for sorting aluminum and light elements more efficient. There are a couple of other applications that I'd like to discuss, like electronics. We can test for many precious metals and electronics, like silver and gold and platinum, palladium, ruthenium, and iridium. There are glass applications where we can test for leaded glass versus non-leaded glass. Copper applications where we can distinguish between copper and brass grades. We can sort over 62 different types of coppers within our copper library. And the last I'll mention is car catalysts. We have an example of one of the top 10 non-ferrous recycling companies that bought several of our units for sorting car catalysts, looking at elements such as platinum, which is the most active catalyst, palladium, and elements like rhodium. So let's discuss some of the challenges for scrap recyclers today. One of the biggest challenges is how to effectively sort aluminum alloys. The importance of magnesium in aluminum alloys at less than 1% is duly noted. Measuring in less than 10 seconds to identify 75% of aluminum grades in the library. The key is when magnesium is the differentiator below 1%, your test will take longer with portable XRF. But roughly about 20% of common aluminum grades will fall into this category. There are examples of these grades, such as a 1000 grade or 3003 grade, a 5086, 5005, 6063. These are all grades that have magnesium at those low concentrations. Those are difficult to sort, but we do have techniques for doing that. The one thing I do want to mention is that sample preparation is of utmost importance when sorting aluminum alloys. Coatings can interfere, rust can interfere, dirt, dust, debris can all interfere with the accuracy and precision of your reading. So here are some tips for sorting scrap. Number one, run the shortest, fastest test whenever possible. Extend your testing only when necessary with Smart Sort. So here's the first tip. It's really important for operators to know when to extend the testing. This is a question we get in the field quite often. Sometimes it can be difficult to know when you're done testing. Again, it's rare that you'll need to use a second beam in a yard, a second beam meaning a longer test. If you have to, we have a technology called Smart Sort that can automatically trigger a longer test to extend your testing times for sorting difficult aluminum alloys. Keep in mind, aluminum alloys are typically sorted by light elements. There are also some coppers and very few stainless grades, such as 303 and 304. In most instances in recycling environment, examples such as 303 and 304 are called 18-8. 303 has less than 1%, 0.1 sulfur, which makes it easier to machine. In most scrap yards, this really doesn't matter. In as little as 1 second, the Delta analyzer identifies the exact copper grades of tested material and detects aluminum levels as low as 11%. This nearly instant detection of the presence of aluminum accelerates sorting and may prevent paying copper prices for aluminum content. If the analyzer is not sure of the material in the first 2 or 3 seconds of testing, using Smart Sort, it will automatically roll over to launch the second beam for a longer test. But this is only when needed. The takeaway is that the instrument is smart enough to make the decision to extend the test time for the user. The user does not have to make that decision. Tip number 2, leverage advanced library features for better results. For instance, this is our second tip, insert a nominal chemistry. When you insert a known quantity of an element into the analyzer before taking a test to account for elements in the sample, it wouldn't otherwise be detected. So adding a nominal value provides for invisible elements, an example being an element that is not tested with a single beam quick test, or XRF invisible elements such as boron or carbon. So keep in mind, the more elements that you can quantify in the sample, the faster you're going to have a material identification. Tip number 3, apply tramp element limits to speed and simplify correct grade matching. Tip number 3, these days the average scrapyard is sorting a quantity of elements that may not have been detected in the past. This has to do with the effectiveness and the efficiency of the technology that is out there. Applying a tramp element limit to the instrument speeds and simplifies grade matching. Essentially, when you account for tramp materials in an alloy, these are common in commercial alloys. You're taking into account elements that can be included in the melt itself. So essentially, tramp library tolerances simplify and speed grade match messaging. Tip number 4, customize and use grade match messages to provide operators with shot-by-shot sorting guidance. This is a common issue. We want to help operators who are unfamiliar with the equipment or may not be confident with their results. We have a very unique feature called grade match messaging. GMM, or grade match messaging, allows the operators to customize messages for certain grades. These are instructions or text messages that it can include things such as alternative grade names or sorting information. So this is all customizable by the operator and can be turned on or off by the management team or the yard manager. A really good example of this would be an instruction for the sorter to, quote-unquote, put 304 stainless in the blue bin, or put 316 in the red bin, or caution, beryllium-bearing copper grade. Please set aside. Tip number 5, protect the analyzer window from sharp objects. This has been an issue in this market with these analyzers in the past, and we provide our customers with a very unique way of protecting the instrument. So when you're testing turnings or other sharp materials, it's important to first always practice proper handling of the analyzer, first and foremost. You've got to use the wrist strap, avoid dropping the instrument, and when you're testing turnings or sharp objects, using a hover method often works better than placing the instrument directly in the turnings pile. But it's always important to protect the analyzer window. So what we employ is a thick window guard that can take up to 8 pounds of pressure from a very sharp object. So this greatly reduces the cost of repair in the analyzer. You're protecting the entire front end of the instrument. All of our instruments are equipped and shipped with the window guard as a standard feature. In summary, these are the tips we provided today to improve scrap sorting efficiency and effort. Number 1, always try to run the shortest, fastest test whenever possible. Automatically launch light element testing only when required. Number 2, use a nominal value to identify nickel and copper grades that have aluminum or silicon with a 1-second test rather than a longer test to directly measure aluminum or silicon. Number 3, apply tramp element limits to speed and simplify your grade matching. Number 4, customize and use grade match messages to provide operators shot-by-shot sorting guidance. And number 5, at all times, protect the analyzer window. Here are a couple additional applications for handheld XRF that are worth mentioning. Number 1 is catalytic converters. Scrapyards also often have a need to evaluate content of catalytic converters. Decanning or opening and testing material inside is often employed. Sometimes it's not. Olympus has partnered with industry experts to develop proper calibrations, which are ideal for the analysis of autocatalyst materials for precious metal content, including platinum, palladium, rhodium, etc. So let's review what types of handheld XRF analyzers that Olympus offers. The first model is called the Delta Classic. This is essentially the workhorse model of our product line. The Delta Classic is a 40 kilovolt X-ray tube. It's a silicon pin detector that has a thick capped-on window and has the ability to do a vast majority of sorting that you may have on your location. If you have a need for more horsepower, such that you want to sort more aluminums, the Delta Professional is a fantastic step up. What the Delta Professional does is it has the ability over and above the Delta Classic for measuring light elements such as magnesium, aluminum, silicon, phosphor. This opens the door for increased analysis of aluminum alloys. And our premium product, the Delta Premium, is really an instrument that is specialized for certain applications. It has a 40 kilovolt tube. It has the largest area SDD detector that we offer in the market, and it really is used for analytically demanding applications, one being phosphorus, for instance, in steels is an application that comes to mind. So some of the unique features of the Delta before we get into the Q&A. Folks often ask, why you better? Well, it starts, number one, with Olympus and the support that Olympus gives our customers. Number two, it comes down to the folks that are supporting you on a day-to-day basis. And number three, the quality of the instrument. Is it field-worthy? Is it rugged? Is it have rubberized overmolds and heat sinks for hot testing when you're out in the field and it's 100 degrees in the shade? You need an instrument that can withstand that type of environment. Is it analytically superior? Does it have excellent superior light element detection? Does it have selectable tramp element limits? Does it have other features such as nominal value reporting and grade match messaging that often will help your productivity while you're sorting in the yard? So why choose Olympus XRF analyzers? Well, they're fast, you get decisive results, fantastic analytics, the fastest ROI in the industry, increased profits, very durable, and they're extremely reliable instruments. So that's about it for me today. I want to thank you for spending the time with me to discuss maximizing ROI with XRF, tips to achieve speed, simplicity, and accuracy for scrap sorting. Thank you very much. Does anybody have any questions at this time?
Yeah, we'll give the folks a few minutes to develop some questions if they need to, and you guys can handle those as they come in.
First question, how does it handle cold temperatures? Excellent, excellent question. Well, in my experience, you have a certain rating for the instrument in cold temperatures, but that rating is mostly has to do with the screen itself. As you know, with any electronics, we have even if I take my smartphone out in the yard and it's 10 degrees above zero, that my screen is going to slow down, and that's definitely a limiting factor, not just for our instruments, but for electronics and cold temperatures. But when considering that the instrument's detector technology within the instrument runs at negative 35 degrees C, the cold temperatures will actually make the instruments, make the electronics in general, outside of the screens operate, in my experience, operate more effectively and efficiently. So the limiting factor really is all of these LCDs and LED screens that you have these days, not necessarily the hardware and the instrument itself. I hope that answers the how does it handle cold temperatures question. Next question is, how about hot testing? Well, very good question. Well, if you take a look at the top of the Delta instrument, what we've done in the design of the instrument is employing a device that looks like a radiator. So that radiator wicks away heat both from ambient heat and also from heat coming from the electronics within the instrument. So considering that one of our largest applications outside of scrap sorting is for testing of in-service hot piping that can get up to 900 degrees Fahrenheit. We do that successfully. Most applications in a yard where it's 100 degrees in the shade don't necessarily affect the instrument, considering it's some of the other tough applications. But a lot of it has to do with the design of the instrument. A lot has to do with the radiator and how we've designed the front end of the instrument that wicks away the heat from the internal components of the instrument. Another question we get is, what are the costs? Well, what are the costs? I usually talk in terms of ranges. So investments range anywhere from $20,000 to $40,000-ish, depending on the application. Remember, you can get into a Delta Classic analyzer and then go all the way up to a Delta Premium, which is specialized for different applications. There's a range there, depending on how much horsepower you need in the product that's going to do the job for you. I believe we have another question coming in. Do you sell or provide references to vendors or type standards to check assay quality? That's an excellent question. Yes, we do. There is a company that we use out of Colorado that they sell round-robin certified check standards, and we've used them quite often. I believe the name of the company is Army Analytical Reference Material International, and they are excellent. And they have all sorts of certified materials there that we can either purchase for our customers or point our customers to them. I hope that answers your question about references. We have another question coming in. The question is it possible to get printouts from tip list? What was that? Tip list to reread? So is it possible to get printouts? So yes, there's two ways that you can get printouts from the instrument. Keep in mind that all of the readings are stored in the instrument, and the readings are stored in a format as such that they cannot be tampered with. But you can essentially generate reports in several ways. We have clients that will use a portable printer that has a sticky tape that spits out of the printer, where you can run a test. It sends the test to the portable printer. You rip off the sticky tape and you put it on your sample or put it on the bin, right? Another way of doing it is to save your results and then generate a one-page document, and we provide you with the software, and it's very, very easy to use to generate that one-page report. So you may have a client where that brought in a bundle or it's a truckload of something, and you analyzed it and you want to send them the report. You can print out a one-page document with your logo, which is pretty nice, to the client in PDF. It's very simple to do. Next question. How does the Delta compare to other handheld XRF analyzers? Well, that's a good question. We get that one all the time. How do you compare? Well, there's quite a few good ones out there, I must say. I'd say the Delta has some very unique design features that make it, I would say, the top instrument as far as ruggedization and durability. That's number one. If you take a look at the design of the Delta instrument compared to other products that are on the market, you'll look at the design and say, put it in your hand, hold the others in your hand as well, and you'll say, boy, it really feels more rugged than what else is on the market. So a lot of it has to do with the design of the instrument. And the second is the analytics. As far as lowest limits of detection for light elements, I don't believe that you're going to find an instrument that's equal out there for measuring magnesium directly. And then some of the unique features that we mentioned during the presentation that really help you make smarter decisions and keep you more productive in the field, like nominal value reporting and grade match messaging and smart sorting. So what we tried to do, what Olympus has done, is essentially take a lot of decisions out of the hands of the user in the field and make a smarter instrument for scrap sorting. Next question, is this the full line of products, the scan scrap? For scrap sorting, the Delta product is our flagship product. We have another product called the Expert, which is a small tabletop instrument. This is a closed beam X-ray system, which is preferred in some regions of the world. The Gold Expert is very small, and it's used on a tabletop and has a chamber that you can take smaller parts and put into the instrument. Right now, there's calibrations with that Expert series for precious metals. And there's also a calibration specifically for looking at restriction of hazardous substances, but no general alloy configurations right now. That may be something we will look into in the future. Next question. Can XRF overheat in a warehouse with heavy uses by day end? Well, I've seen that or heard that with other products in the past, but as I had said earlier about the design of the instrument, they would have to be extreme conditions for our XRF to overheat. It's certainly in a warehouse with heavy usage by day's end. Simply put, the design of the instrument wicks away that heat from the instrument, and it should not be an issue. That's not something that I've run into in my personal experience. Someone asked about step-by-step instructions. We offer user's manual and videos on our website and YouTube channel. So we have, if you have an existing analyzer, this is one of the strengths of Olympus, and is we have a direct sales force within the United States that is always available if you have an existing analyzer for retraining. You know, we have manuals that ship with the instrument as well. If you contact our service department, they can provide you with service manuals. These are, we have plenty of tools at our disposal to help train existing customers. It's part of the benefit of doing business with Olympus is that we have the means to pay attention and really pay attention to the needs of our customers. Next question. Best techniques to measure thin wires, jewelry parts, less than 1 millimeter or less than 1 millimeter. Really, really good question. We have two options for testing small parts, which I would recommend. Always practicing ALARA, right? ALARA is safe practices using X-ray fluorescent instruments. So the first thing I would recommend with small parts is to utilize a test stand. This is where you dock an instrument into a test stand and you put a small sample into a chamber, close the chamber hood, and then test it. That's the best way to test really small parts. There are other techniques for measuring thin wires. Keep in mind that if you take your instrument, lay the thin wire down on the table, and test the thin wire on top of the thin wire, you're measuring the table, you're measuring the wire. If you can find an object, and I've often used, I think works pretty well, is the foam that comes in the carrying case that the instrument comes with. Doesn't have any elements in it that I know of that will affect the reading, and that is a pretty good solution for putting a thin wire down on that foam and testing the wire. But it's a really good question because you want to avoid at all costs testing samples or in your hand, or you're putting your hand. I see the mistake where users will take the wire and shoot the wire in the air with their hand right underneath the instrument. Well, there is backscatter coming off of the wire onto your hand. Now, that's not best ALARA practice. So I would say you either a test stand, and we have several options. We have a small workstation, and we also have what's called the flex stand, which is a very inexpensive test stand, or use a background, but also always practicing ALARA techniques. This is the last question of the day. The best method for large piece bins with sorted scrap, pieces verifying in content allotment. So if I understand this correctly, the question has to do with large pieces in a bin when sorted scrap. So I would assume that you're looking to average the scrap within the bin. Now, there are averaging features within the instrument. So if I'm answering this correctly, I hope I am. Thank you very much for the question. But there are averaging features with the instrument where you can take 5, 10, 15 tests, and if you're taking 15 tests, you want the 16 tests to be the average of the bin. That's always a possibility. Those are features that are built into the UI of the instrument, of the Delta itself. So very efficient way of averaging pieces that are in a large bin. So thank you for joining us today. I appreciate you setting aside the time, and please take a look at us.
Thank you, Eric. On behalf of Olympus, I'd like to thank all the attendees for joining us and Eric for his participation in today's event. We hope this material presented was informative and useful. This webinar, along with the Q&A session, will be archived on our website at www.olympus-ims.com. Everyone who registered for this event will receive a follow-up email with links to the archived presentation. That's going to do it for today. Again, thanks for participating, and we'll see you again next time.